Okay, so I waited for the next day to film this video, and I guess you can see I haven't shaved since then. But it's a little brighter now. The last video, you can only see half my face. Sorry about that, but it seems like students like it better when you guys can see my face. Anyways, here's the pre-lab for number 3, lab number 3. And a lot of this, I don't want to go over this too much because you've seen this in the lecture already. So, but the NASA space probe, they made the wrong conversion, had a bit of an accident there, and I'm sure a couple of people got fired. Anyway, so here this is high precision, so it hits the same spot but no accuracy. Accuracy hitting the target, it's off the target. This is low precision but higher accuracy, see it's all over the place. It's like shooting a machine gun at a target, missing everything. And this is high precision, high accuracy. Of course, we want to have this is the ideal. Actually, the truth be told, this is the second idea. It's better to be precise than in this regard, so your results are much more reproducible. But going on, so sig figs, we're going to go through this a bit. Usually for your lab kits, these things are made of plastic, so you're not going to see too much of a meniscus. If you have something made of glass, then you're going to have a meniscus because the glass, it's silicon dioxide is mostly what glass is, and hydroxides on the surface, so there's going to be an attraction there with the water. For plastic, it's just a hydrocarbon and there is not really any attraction whatsoever. Well, there's at least not for the water. The water's more attractive itself, so it'll be really flat. So you're not going to see a meniscus if you have plastic materials, and usually these things have plastic materials in them. So if you don't see a meniscus, don't worry about it. So sig figs, for sig figs, of course, you count after the zeros. This one here, these 3 zeros don't count. 2, 5, 6, 4, 0, 1. These here are the sig figs after that. And then here going over these well, 2, 5 should answer this one. There's 1, 2, 3, 4, 5, 6 on this. There are 1, 2, 3, 4, 5, 6 in this. This one's undeterminate. It's either going to be 3 or 1, 300 being the first one. Since it's not in scientific notation, this is going to have 3. This one's going to have 5. This one, and the 0 after that counts if you have a 0 after it. Why don't you just call it 2.02, 2.020. That tells us that we're sure about this last 0. So, although this is more or less kind of indeterminate, by the rules it would be 3. This one is going to be 4. For instance. So, in adding these, when you add numbers, you're only so sure as far as you know. You can't go past the 1s in this one here. Oh shoot. You can't go past the ones at 155 since you're not sure after that. Here you can't go past the tenths. Here again you can't go past the 1s when you do these. See, the answers are like that. And for multiplying, you have 2 sig figs here, so your answer is going to have 2. Same thing here. This one has 2 sig figs, so the answer is 2 there. And 0.57 is going to have 2. So you have to go with the one with the fewest significant figures. And you see here, these all have 2 sig figs. So, and one thing with measuring, so different philosophies. You can, if you want to look at Zeno's paradox, you know, that kind of stuff, that might be something fun to look up online if you want more stuff. But, you know, when we do science, we're only so sure about what we're doing. I mean, we're limited by experimentation. So what we know in science is what we can prove experimentally, and we only know things so well experimentally, and that's one of the limits of it. And it's the measurements that we do. Sometimes measurements are better. We're getting better at some of them. Sometimes they're not as good. But I mean, for this class, so I mean, this is not research grade. This is just to illustrate, you know, what's going on in an educational standpoint. With really ultra fine machines, we can get some really good data. But this is not as nearly as accurate as things are. And okay, so we've talked about this is dimensional analysis. This is shown quite a bit in the lecture class, and so on. So what are we doing in this? So this is all review from the lecture. What are we going to do in this lab? We're going to find the density of water. Density is an intrinsic variable. That means it doesn't change with mass. Or I'm sorry, it doesn't change with size. So if I have a cup of water, if I have a drop of water, and I have a lake of water, water is going to have the same density, right? It doesn't matter if it's a drop, if it's a glass, if it's a liter, 2 liters, 5 liters, 10,000 liters. water has the same density. Density is mass divided by volume. So we're going to do this, and we're going to use the ever difficult, dangerous chemical of water, and you're going to fill up a cylinder and weigh it. And the volume, length, width, height is your volume, and the volume of the water is that, and the mass of the water. So mass of the cell, you're going to weigh the cell, weigh the mass of the water in the cell, and then subtract the two to get the mass of the water. And you have density, mass divided by volume. There we go. Density is mass divided by volume. So from that you get the density of water. And the density of water should be 1 gram per cubic centimeter. So that's what, 1 gram. Cubic centimeter is the same thing as a milliliter. So if you measure something in centimeters, you get cubic centimeters. A cc is cubic centimeter. That's the same thing as a milliliter. So you got that, and if you want to do okay, percent error accepted value, this is 1 minus the experimental value. So let's say that you got the mass of water being 0.98 grams per cubic centimeter. So 1 divided by 0.98 is 0.02, divided by 1 is 0.02, so it's 2%. So if you get 98, so let's say you get 102 or 1.02 grams per cubic centimeter as your experimental value. This is an absolute value, so 1 divided by or 1 minus 1.02, that's negative 0.02, but the absolute value is 0.02, so you can have your experimental value be over your accepted value, because this is the absolute value here. So remember that, that you're not going to have a negative number here. That's always positive. So do this, let me know if you have any questions, and submit it when you are done.